Hello and welcome back to the solution videos for the Marquette Programming Competition. For the second problem here, we're going to be calculating the least common multiple of two integers. We're going to be doing it in this skeleton right here. So the least common multiple is just the least number that is a multiple of our two numbers. So a good way to calculate this is this function right here. We actually multiply the numbers together and then divide by the greatest common divisor, so the number that divides both a and b are two numbers. Now the way that this function is going to work, we can actually see it with a nice example here. So 8 and 10, if we consider 8 and 10, multiplying them together we get 80, and then the greatest number that divides them both is 2. 2 divides 8 and 10, but there's nothing bigger that divides both 8 and 10. So 40 we find is our least common multiple. Now we can see how this works if we look at the prime factorization of all these numbers. So we break up 8 into 2 times 2 times 2 as the primes that multiply together to give us 8. And then 10 is 2 times 5, 80 is 4 2's times 5, and then 2 is just plain 2. It's prime by itself. So the multiplying the two numbers together, 8 and 10, you can see it's just multiplying the two prime factorizations together. So we take 2, 2, 2, and then a 2 and a 5, and we just multiply them together like that. And that's how we get 80. The greatest common divisor, we can see, is the common parts of our two numbers. So 8 and 10 both have just a single 2 in common with them. 8 has more 2's, but 10 doesn't have more 2's, so we only include one of them. And then the 5 isn't a part of 8, so we won't include that either. So that's how we get the bottom part of our fraction. We just take the common parts of the prime factorization, and that is the largest number that will divide both of our numbers. And so this result, 40, then, we can see is a multiple of 8 and 10. We can confirm that. A number is a multiple of some other number so long as it contains that number's prime factorization. So we can see that 40 is a multiple of 8 because we can see a 2, and a 2 in there. So we know it's 8 times the rest, 8 times 5. 10 we know is a multiple of 40 because we can see that 2 and 5 in there. And we also know it's the least common multiple because we've done this division here. We've taken out the extra parts. So here we kind of double counted one of the 2's. We needed a 2 for both 8 and 10, but we put in more than we needed. We can still get away with seeing 8 and 10 in the prime factorization without that fourth 2 that we included. So dividing by the greatest common divisor is how we get that least common multiple instead of just any multiple. So let's go implement this in code. So here's our skeleton. And our simple function is just our a times b divided by, and then we're going to make a function for this, the greatest common divisor of our two numbers. So let's write that function now. So we'll just take in two integers, and this function is going to return that greatest common divisor. Now a good way to do this is the Euclidean algorithm. So you can just see online for that. There's many videos out there explaining the Euclid's algorithm, but the bottom line of it is that we're going to keep taking the greatest common divisor of the second number and then the first number mod the second number. So this second part here is going to return the remainder when you divide by a, or divide a by b. Now eventually this has to stop. This is a recursive function here. It'll just keep calling itself, but our base case is essentially when one of these numbers gets to 0. Specifically the second number here. So we're going to throw in an if statement here. If our second number is 0, then the first number, is our greatest common divisor. That's how this algorithm works. And so there we have it. This will return our greatest common divisor, and then we'll plug it into our function for the least common multiple, and we should see our results. So let's try that example that we were working with. So 8 and 10, we see we get back 40. If we do, let's do a bit larger one. So 30 and 24, we see 120. So we multiplied those together to get our 720, and then 6 divides both of those two. So we took that out of the prime factorization like we saw before. So this is how you do the question 2 for our programming competition.